Okay, this is a tutorial series on Hypernodes, and this video is about storage, storage within the graph. Now obviously if you're building a custom client, maybe you'd rather have your client control the storage. It's a little cheaper, I guess, if you want it stored locally, a little safer to have it stored locally on the device of the user. But you can also supplement that with storage inside the graph. And obviously, if you're using the Discord bot, if you're using any of the built-in clients, you want a program that's entirely in the cloud, you need storage inside that system. For that, right now, we have the concept of mailboxes. Mailboxes are designed to store this human readable text, these messages, maybe character sheets or conversations, comma separated value, data. Mailboxes are kind of a queue system. So there's the concept of peek versus get. If you peek in the mailbox, you don't take the mail out. It's still there if you want to go back again and peek at it. But if you get it, it's taken out of the mailbox, and that message is not going to be there anymore in that mailbox. Mailboxes are a key value storage method. So if we look at the mailbox put node, you can see it has a key, and this key is it's the address for the mailbox, you know? Let's make a key test data. And let's have just an easy graph that will store something in a mailbox. Just leave it as output to see what happens. And you get the true when it successfully stores it. Mailbox get one. Gets one item in a mailbox. And there can be multiple items in a mailbox. So actually, why don't I show you multiple items in a mailbox? Now we'll put output 2 in the mailbox. It's in the same test data mailbox. Okay, now mailbox get one node. Take this key and I'll just do an also node. So it looks like I got this item in the mailbox that wasn't something I put in. Someone put this item in before I put my item in. If you want to use mailboxes, you're going to need to be aware of the security of doing so. The mailboxes are all publicly accessible, but you can put 60 characters of entropy in the mailbox. So if somebody can't guess your mailbox key, they're not going to be able to look at your mailbox. They're not going to be able to modify your mailbox. And if you have a whole API key worth of entropy in your mailbox key, nobody's going to be able to guess that. So your mailbox is going to be safe. But if you just use like test data, well, that's a public mailbox because other people are probably going to use that too. And so if you want to have labeled mailboxes that are human readable mailboxes, you're going to want to paste together, say, test data onto your private key in the mailbox. So if you want to make this private, you could have a concat node, you can paste test data on, you can have long string of gibberish that represents your private key. And then nobody's going to be able to guess the resulting mailbox key. But for the demo, I will keep it simple and I will just continue using test data. So let's get everything from the mailbox. Let's get everything from this test data mailbox. I believe we'll start running into the ones I put in earlier. Yes, we got the next item and it was the first item I put in output. And then run it one more time and output 2. And now run it again and there's nothing. Okay, so the mailbox is empty. Why don't we put a few items in? If you'll recall, you can send multiple messages from an input node in our editor using this conversation editor. And I can add another message and run it. Okay, so should have 2 items now in the mailbox. So if I use the get all node, works the same as get one. Okay, let's test out the get all node. It takes a little bit longer than the get one or the peak, but there's the result. Looks like it got added to 2 times, so it pulled out 2 iterations of this data 1, data 2 conversation. Well, that's it for the mailbox nodes demos. It seems pretty straightforward. For the rest, you can read the descriptions. If you don't like the queue paradigm with the mailbox replace and peak, they're probably your bread and butter if you're using mailbox to store just a single item. So you don't have to use get and then put whenever you want to read it. And of course, replace is very convenient, so you don't have to get all and then put. Because anytime you try to use 2 nodes in one graph, there's no guarantee that they're both going to execute. It's rare, but sometimes the graph will crash in the middle. So if you want your data to be stable, definitely use peak and replace. And finally, the mailbox wait node. Well, it waits until there's something in the mailbox. So this could be quite a long wait, and it won't persist through the server restarting. But if you have a program that you need to synchronize on a mailbox being loaded before you then peek at the mailbox or whatever you do, this is the node for you. It just takes in the key and it'll output that same key, so you would probably just put it right in the middle here as a way to make sure that the mailbox has something before you use get all. And you always want to use it as a pass-through for the key in that case. Now, some general information about mailboxes. They are the Azure storage queue. So the data in these will persist through server restarts. They don't expire. Well, they expire in like 30 years. And that's only if you don't replace the contents. So one limit to the mailboxes, which are Azure queue storage, each message, meaning each individual item in the list. So if you put one item in and you use get one instead of get all, The limit of size is 64 kilobytes, which is, well, 64,000 characters. That's probably over the context limit for most LLMs. However, you may want to break it up with a split node before putting it in if there's an issue. Also, the cost for mailbox nodes. They do cost a few tokens. It's not very much, and most of the tokens are when you add a new message to the storage queue. Because when you use the mailbox node, you are paying in advance for storing the data on the servers. But it's not very expensive anyway. It'll be far less per token than calling ChatGPT. Alright, and that's about it for storage. Hope you enjoyed the video. Hope it was clear. Next, we'll be talking about the more miscellaneous web requests, math node, client function node a little bit. So see you then.